whole setup, starting with the image.
Dave, this is an overview of what the problem is, and I hate to try to go into too much detail, but we want to show you the equipment up close. So the camera looks at the grayscale. The camera is a black and white professional camera, and it feeds into the vp8 here. Come over here and take a look at the vp8 circuit. Okay. I don't think you've ever seen this, but it is a 1960s discrete components, and I've had to service electrolytics and parts on this board too. So, but this sucker works. Now, it outputs several things. It outputs to the monitor over here. Now watch what happens. It can actually divide, it can actually slice the image in 8 sections, and so this is what gives the image, this is why it's called a vp8, because you can slice the image, and that was how it came into existence. But the most important feature, of course, is the three-dimensional display over here on the 1300A. Now, you remember that you replaced a number of capacitors in here, and remember we had the high voltage trouble, but you fixed that. So actually you can see it jumping around, but here's what I want to point out, that it settles down. In other words, when I knock it, up here it doesn't do anything, but back here where the 2 input cards are, the X and Y amplifiers are back here. Zoom over the top again.
Okay. Down
here are the 2 cards which we suspect have a leaky electrolytic in the input, because this line that's going through here, this black line, is the interference of the video 59.6 hertz competing with the 60 hertz. So in other words, this is a 60 hertz signal sneaking through at 0.4 of a hertz, and that's what you got. Now the only thing I can do is I can change the gain. I can change, well, I'm sorry, not much.
Okay.
Well, here we go. I can show you this. If you look, can you get these lines? See if you can get these little lines here.
Yeah.
Do they show up?
Yeah. Well.
All right, this is a 5 megahertz scan signal. You can see the fineness of the scan, and here's the important point. It's in real time. Watch as I go through here. See how it actually turns out to be in real time. I'm using this to interrupt my signal. You can see over there on the screen, the input screen.
Yes.
You can see how it is actually in real time and is actually going through this thing. So see, okay, here you can see it here.
Mm-hmm.
Here, Dave. So you can see how it's going through.
Yeah.
So this real time feature is what the Chinese want. By the way, they are coming on the 16th. That's in 2 weeks.
Yeah.
So that's why we've tried other things, and we cannot find a new one. Well, these haven't been made in 40, 50 years. So this is a real jewel insofar as, yeah, sure, an oscilloscope will work, but, yeah, not...
Let's see if that helps.
All right, I don't know if that helps. Yeah. We suspect that this is the card. This is the Y card. This is the X circuit. You can see they're very similar. And the connections down here, of course. But, well, anyhow, we'd like to make one last attempt to get this cleaned up for the Chinese. By the way, I can show you that we have the relief here. Okay, let me show you what this does. This is the phase change to allow the base to rotate, and we even have a thing over here which tips the base. So we are working in real 3D modeling with the analog XYZ display, and there's no doubt about it. The fact that it works almost almost perfectly is what's driving us nuts, because
we're so close. It's got to be something simple.
Yeah. So
okay,
this is the problem.
So that sums it up, right?
All right, that sums it up.
Okay. All right. Thank you.